Welcome to True Projects. In this video, we will be explaining about Pmool multi-objective optimization in Python. Introduction. Increasing demand for optimization frameworks in data science, machine learning, and deep learning projects, we introduced Pmool, an influential multi-objective optimization framework tailored for Python. By addressing the need for comprehensive tools to handle multiple conflicting objectives, Pmool offers versatile functionalities and customizable algorithms. Emphasizing its modularity and extensibility, the architecture of Pmool is explored. This introduction showcases Pmool's capabilities, featuring parallelized function evaluations, automatic gradient retrieval, and visualization tools for low and high dimensional spaces. It highlights how Pmool has become indispensable for researchers and practitioners seeking efficient multi-objective optimization solutions in Python. Objective. The main aim of the project is to present and highlight the capabilities of Pmool, a multi-objective optimization framework implemented in Python. The project showcases how this library offers diverse optimization algorithms to either minimize production cost or maximize production efficiency. Through a practical example using a polynomial expression, the project specifically focuses on employing NSGA2 algorithm iteratively to discover optimal solutions with minimize and maximize values as 0. The core objective is to provide researchers and practitioners with a flexible and efficient tool for tackling multi-objective optimization problems effectively. By doing it so, it benefits various domains including computer-aided design activities and other optimization-related tasks. These are the requirements for execution. First one is hardware requirements. Operating system of Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above are required in hardware requirements. Coming to software requirements, Python IDE of 3.7 version is required. These are the design modules for execution. First one is to initialization problem. In this module, we initialize the optimization problem which we want to solve. The problem involves defining the number of variables, objectives, and constraints as well as specifying the lower and upper boundaries of each variable. Next one is initialize optimization algorithm. In this module, we select and initialize the optimization algorithm which we want to solve the defined problem. For the given project, NSGA algorithm is chosen and set up with specific parameters like population size, number of offspring, and sample method, crossover and mutation rates, etc. Third one is to find optimal solution. In this module, the initialize optimization algorithm is executed to find optimal solutions for defined problem. The algorithm iteratively generates new solution by performing mutation and crossover on the initial population. It evaluates the fitness of each solution based on the objective functions and constraints defined in the problem. The algorithm continues iterating until it finds a satisfactory or optimal solution that meets the defined criteria, such as reaching the specified convergence criterion or the maximum number of iterations. Fourth module is design space graph. After finding the optimal solutions, this module visualizes the results in a design space graph. Fifth one is convergence graph. This module visualizes the convergence of the optimization algorithm during its execution. For execution of the project, first open the code folder. This is the code folder of the project, and this is the main code file, and this is the run.bat file. Instead of executing the project in command line interface, we have created Windows batch file for execution. So double click on it for execution. This is the graphical user interface of the project. With this, we can interact with the program, and this is created by using ticketer library in the Python. So first click on the button initialization problem button to define the problem. Here problem is initialized. Now click on the button initial optimization algorithm to initialize NSGA algorithm. Here algorithm is initialized. Now click on find optimal solution button to find optimal solution for polynomial expression problem. Here algorithm run for 40 iterations. For each iteration, it has found that the value is less than or equal to 0, which means the optimal solution is less than or equal to 0. To see the optimal solution graph, click on design space graph button. Here, the black line represents required solution as 0 and red small circles represents optimal solution which are less than or equal to 0. So all the circles lie on the black line, which indicates algorithm has found optimal solution at last iteration, where red circles is a complete middle of black line. Now click on button Objective Space Graph button to get objective value at each iteration. So here the black line represents optimal solution which is close to 0 as our objective function. In the graph, small circles represents the values obtained from algorithm, and black line on small circle represents optimal values which are close to 0. Now click on the button Convergence Graph button to get the graph. Here in the code, we have given the generation value as 10 and population value as 40. So 10 into 40 is 400. So here we have the 400 iterations, and in the graph, x-axis represents the iterations and y-axis represents the optimal solution. This graph represents line graph. Line represents count of iteration and small circles represents the optimal solution found in that iteration. Close this graph. Close this GUI. Conclusion: the project successfully introduces and demonstrates the robust Pmool library, a Python-based multi-objective optimization framework, by effectively solving a polynomial expression optimization problem using NSGA2 algorithm. The project showcases the versatility of Pmool. Users benefit from flexibility to define their own optimization problem and effortlessly customize algorithms. Through insightful graphs and visuals, the algorithm efficiency is iteratively finding optimal solutions for both objective functions and constraints. It highlights the conclusion, emphasizes Pmool as a valuable resource for researchers and practitioners, offering comprehensive support for diverse multi-objective optimization tasks, making it an essential tool in the field.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.